So I don't know if Mark actually knew this when he asked me to host this conversation, but I spent about a year and a half trying to bring new and interesting people into space exploration. And so I am not just personally, but personally very excited to host this conversation with Michael Sims. And I thought I would set the stage for it a little bit by first asking about, you have spent a big chunk of your career at NASA. And so I thought maybe you could tell us how you got into that and what you did while you were at NASA.
Yeah, I was recruited out of graduate school, so that's where I got into it. I grew up with space and robotics as part of my science fiction heritage, and it was the most exciting thing to do. So that's how I got into it.
And so you're recruited out of grad school. You show up at the NASA offices, and they ask you to do what?
Well, my assignment was to do AI and robotics. I mean, that's what I was supposed to do. And
big evolution between then and now.
Yeah, I founded a robotics lab there. And it was a quirk of nature, quirk of circumstances that when I first arrived at NASA, that I was actually got a job which most people would have taken most of their career hoping to get, which was I was in charge of AI and robotics and human factors for all future human missions beyond Earth orbit. So that was sort of like, became the thing I got on day 0. And after a year, I decided, great to have that when you first start your career, rather than at the end because you decide how little power there is.
So you were deeply involved in a lot of the robotics missions at NASA.
Yep.
In fact, you drove or operated. What's the right term? Operated?
As part of the operating team.
Okay. And so there's a team of people, and you're one of them, and you're operating these robotic machines on other planet surfaces.
Yeah.
First of all, how many people get to do that in the universe?
Not many. In Pathfinder, it was probably a dozen, maybe 2 dozen. In MER, maybe 100.
That's a pretty small number.
Yeah.
That's fewer than people who have gone to space, I think.
Yeah, I'm sure.
All right. So, we were talking the other day, and you said that in fact, driving on Mars is easier than driving on Earth.
Yeah.
So, can you unpack that for us a little bit? Why is that the case?
Well, fundamentally, let's just look at the autonomous driving on Mars versus autonomous driving on Earth, right? So on Earth, you're traveling, well, most of you know it's like driving a car to do an autonomous vehicle. It's like driving a car at highway speeds, and you have to respond to things around you. You have to look at circumstances. You're careful about obstacles like people. You're careful about holes in the road. When you're on a planetary surface, I mean, it's a natural terrain. So there are different things you worry about. You worry about slippage. You worry about, there's a whole suite of things because you happen to be a spacecraft that you care about being a spacecraft. So you care about the power that you're receiving, things like that. But fundamentally, the sort of, if you did a ledger sheet and you said the amount of things you have to worry about on a Mars surface or a lunar surface to autonomously drive, it's a smaller set than the set of things that you have to do on Earth.
So what are the implications of that for how we handle robotics in space, right? The environment is totally different, but it's not man-made. How do we take that and bring it into our thinking and design for robotics and AI in space?
So the first thing is, obviously robots on a planetary surface, if you've looked at Mars, robots, they travel slowly. They don't do things very quickly. And there's a tendency to interpret that because people aren't interacting quickly enough, and that there's a time latency between that's causing that. That's not actually the source of the problem in their speed. The source has to do much more with data that gets transmitted back and forth, and how you can analyze that data. And it's also associated with how much autonomy is on the vehicles. Most of our vehicles that have traveled so far have very little autonomy on them.
Yeah, and so and it's interesting that you call that a problem too, because in one sense you can look at that as that's almost a benefit. If you're trying to operate something on the planet Earth, all kinds of things can get in the way in the middle of the procedure. If you're on Mars, nothing's going to bug you. It's
Yes, that is true, but you're also dealing with a spacecraft. So there's a tendency to think of robots on a planetary surface as a robot on Earth. Right? And they're really fairly different creatures for a number of reasons. The primary one has to do with this. A robot on Mars or the moon is a spacecraft. So if you don't manage your thermal environment properly, you're dead in a day. If you don't manage your data volume and how you get data back and forth, you're dead in a day. If you don't manage your power system, you're dead in a day. So that doesn't happen on Earth. Earth, if your Tesla stops driving and you run out of gas or whatever, you pull over the side of the road and somebody comes and fixes it. But on a surface like Mars, you're dealing with a spacecraft. You have to be really careful to manage all those components well.
I'm going to ask about that later because I think there's a good hook for that in a little bit. But all of this suggests to me that AI may have a larger role to play in sort of the near future of robotics in space than a lot of people are currently thinking about. Can you maybe enlighten us a little bit on what that role might look like and what your thinking on that is?
Sure. So let me talk about autonomy and avoid the issue of being careful about how I define AI. So a system, in my definition, a system is more autonomous if humans do more of what they want to do and less of what they don't want to do. So and a lot of AI falls into that category, and some of it doesn't, but most of it does. Under that category, when we design a vehicle, or when we're worrying about AI on a surface, there's a whole suite of things we have to take care of. Right? We'll come back in a moment to the issue of affordability, but one of the big drivers is the affordability, right? And so AI, when we do a robot, there are costs associated with buying the robot, and there's costs associated with operating the robot, right? So autonomy helps us on both of those, right? So and particularly in building the robot, tools like the tools that link 3D out front, and also in terms of development, like ActTag, the other guys out, Murray's company.
Aptage.
Yeah, thanks.
Thank
ActTag. Thanks. Those are very relevant to the kind of things we're trying to do, and those are advanced technologies that are critical in the part of the system in which you're building it up. Right? There's also autonomy that needs to go on the vehicle itself, both to make it safer, to make it faster, to make it easier to operate.
So we've been burying part of the lead here, which is that not only did he operate robotic systems with NASA for how many years?
20 plus years.
20 plus years. Michael's also founded something called Sirius Robotics, and there are a couple slides actually. I think if the AV house wants to prop it up, and I think this is a good time to ask you a little bit about Sirius Robotics. Tell us what this is and a little bit about why.
So there are basically three things I wanted to get across today. One was that humans are just about to become a multiplanetary species. It's not inevitable, but it's pretty darn likely. The second point I wanted to get by was that critical in that process are going to be robots. And the third point is that the critical parameter in all of that is affordability. So what you see in this slide is a screen capture from Elon Musk's recent talk in which he has big frickin' rockets landing on moon.
Family-friendly conference, big frickin'.
Yeah. BFR. And you see several of them, right? So and the crux of what Elon has been focused on in this, and several other companies have been focused on, is making the getting there, the getting to the surface of the moon, getting to the surface of Mars and elsewhere affordable. And what we in Sirius Robotics are focused on is making the robotic task and the things you do on the surface affordable, so the doing there. So once you're there, being affordable. So the thing I wanted to point out, and if we look at the next slide, it'll be even a little clearer. The next slide is in the background you have a capsule, which is similar to a Dragon capsule, or it could be an Orion capsule, or whoever's. But basically, in the past when we got robots to the surface, we sort of came down and most of those, and the spacecraft just zipped open. And then the rover rolled off, right? That's not going to happen in the future. They're going to come down like closets, packed closets. So you're going to have to unpack it and get things out of it. And this is an example of one of those landers. And what we as a company are going to build are robots for the moon, Mars, and asteroids to help in the process of building structures and doing things. And in this case, you see one that's helping in the process of unloading this particular lander.
Now, you talked earlier to me about, a lot of when we have problems or errors in our efforts to move out into space, it's sort of because we are operating at the limits of our human capacity to just handle complexity like this. And in fact, unless aptage kicks in, right? That's where errors come from. And so that strikes me as an area where marrying AI and robotics can really take us forward. Do you want to comment on that for a moment? Or
yeah, so I mentioned before that I was involved in NASA sort of programmatically understanding what the AI and robotics and human factors we did in the future. And what became really clear to me in those design processes is we were designing at the level of human complexity that humans could manage, right? The missions were too complicated that we made assumptions all the time that you just had to make in order to proceed. And when there were shortcomings in a design, they really were not that people couldn't think of it. It's just they couldn't manage all the components together. So AI systems in general are going to give us tools which allow us to have flexibility and get in and make a difference in those. One additional thing I wanted to say that I forgot before, which is that as we become multiplanetary, that's a really big deal, right? The last time humans expanded to next to the last time humans expanded to a major landmass was when we went to Australia, and that was 40,000 years ago.
That worked really well for those large animals.
Yeah, it did. It's going to work really well for the large animals on the Moon and Mars, too. But 20,000 years ago, depending on what theory you believe, but roughly 20,000 years ago, we began expanding into the Americas, right? So what we're doing right now is we become multiplanetary and get new planetary surfaces on which we as humans and our ecosystems are going to live, is something that happened on the scale of 1,000 generations. So most of us have trouble remembering what our grandparents or great-parents were doing at a given moment. But think of 1,000 generations back was the last time an event of this magnitude occurred in humanity. And that's what we're stepping up against. It is a big deal for humanity, this process.
So the stuff you're doing, so a couple things strike me about Sirius Robotics that I think are pretty interesting. One is, the fact that you're doing it tells me that you have a lot of faith in the fact that right now is in fact the time where we're stepping into this multiplanetary, new ecosystem transition.
Yes.
And I wonder if you could tell me a little bit about why you are so confident that now is the time for that.
Well, I think it's still a possibility we could fail at that process, but I don't think it's very likely. We're on the way down a very steep hill, and there might be valleys that slow us, but it's not likely. Is
there a technological piece that has fallen into place? Is there a cultural piece that has fallen into place? What makes now the time?
So the technology that has come along in the last 20 to 30 years is certainly significant. Computational units becoming smaller, the ability to control those with software systems in the robotic realm, things like D-Star and ROS, make the whole process much easier. But as it is right now, we sort of understand the technologies we need to do this game. What's really drastically different, I think, this year than it was 10 years ago is SpaceX and its similar companies that have really aggressively addressed affordability for the launch process. And Elon Musk has proposed that how do you define what it means to be multiplanetary? So Elon defined that to be 1 million people off planet. That's a lot. Jeff Bezos actually uses a similar number. So, and the projected time for that is 40 to 100 years we'll reach that kind of number. But those are numbers which are not reachable by building rockets the way we've built rockets before. Those numbers are not reachable by doing surface operations the way we've done it before. When we operate a robot on a planetary surface these days, we take, typically there's at least a dozen and typically several dozen. You're talking minimum of $10 million a year in operations costs because there are dozens of people sitting behind it. Our commands, we uplink to a robot, effectively assembler language, and we go through by hand in large groups that assembler language to make sure we didn't make a mistake. So we destroy this $100 million resource. That's not how we can live in the future.
Well, it's interesting. That's an interesting example because I happen to know, in my mind, one of the poster children for sort of the new attitude towards this kind of technology is Planet Labs in San Francisco. And they send up hundreds of satellites. They send up satellites all the time. And they know that all the satellites are going to burn up because they're going to low orbit and they're dropping into the upper atmosphere, and they're done in 2 years.
Yep.
So nothing they send up do they expect to last longer than 2 years, and a lot of it shorter. And it's a very different approach to than what you were just describing, going through little sort of line by line with a magnifying glass. I don't want to destroy this $100 million thing to, we got 4 dozen more of those.
Yeah, I mean, it's a great example. Planet and the other set of companies that are building low Earth orbit constellations. First, they rely on advances in avionics, in electronics, and advances in building of mechanisms that we've had over the past few decades. And secondly, they rely on the fact that it's cheap to get them up there, right? So the reason it never made sense to build a $100,000 robot for space, I mean, typically they've cost hundreds of millions of dollars, right, for robots for planetary surfaces. The reason it doesn't cost $100,000 is because it's still going to cost you $500 million to get the robot there and do the things you want to do, historically. So it didn't make sense to cut that so closely.
Yeah, the equipment was a rounding error when you look at the whole enterprise. So who cares if it's 100 million?
Right. So once you can bring down the price of launches to orbit, then you have the opportunity to bring down the overall price. And so Planet launches dozens. Some of them fail, some of them fall back to Earth on a regular basis, but that's part of the doing business. The MER rovers, cost $600, $700 million total. The Curiosity rover and the 2020 rover for Mars are about $2.5 billion each. So that's the world in which I think we have to make serious disruption, and that's really what Ceres is about. Ceres Robotics is about.
So I think of this period we're in as we're sort of in the later stages of kind of an awkward handoff between the government doing things and the private sector doing things. We had this actually, I think a good analogy is actually the transition of sort of a lot of government investment in internet infrastructure got handed over to the private sector, and then we watched this sort of giant exponential boom that we're still part of. And I think we're maybe on the tail end of that handoff here. And there are some things, in your opinion, I think this is really interesting, that government wouldn't be able to do. There's some things that government, is just not good at in terms of pushing us forward. And I wonder if you could elaborate on that for a moment.
Sure. So government is really great at a lot of things. I don't really want to imply otherwise. And part of this process, opening up space, it's been essential that government play many different roles, right? But if I look at the history, what I would say that government has not been very good at is managing and supporting a domain in which there is a steady or exponential decrease in cost. So if you look at integrated circuits, the government was involved in a lot of that early on, but it really took the private sector and its competitiveness to pull in and to push those prices down that gave us the information technology revolution that we've had. So the government And I think the same thing is happening here. The government in space exploration is really good at going out and doing a one-off and understanding the principle and supporting strategically things that are going on to give us the levers we need to make progress. But I don't think it is or will be very good at the kind of things that SpaceX is trying to do. SpaceX believes there's going to be 1 million people in space, right? You don't really understand SpaceX until you realize Elon Musk takes that incredibly seriously. Everything that company does is driven by getting ready to launch 1 million people, right? So what does it mean to launch 1 million people? You can't afford to do that the way we do it. So his goal is bringing that price down so that each individual can afford to pay for it. And what does that mean? That means about maybe taking a stab at a price of a California house. So a few $100,000, right? There's probably 1 million people that can afford to pay a few $100,000 and will willing to go to space. So if you look at something like SpaceX, it's driven by getting the price to that zone, and it will be. So it's happy to throw away its Dragon. It's happy to throw away its Falcon and the Falcon 9 if they are not on the path, on the best way to that pathway to lower prices. So,
Yeah, it's not something you see from a government program typically. It's like, that works, don't throw it away.
Yeah.
So one of the things that I'm a big believer in is this idea of new knowledge coming from different sectors. And by the way, this is probably my last question because we're down to already like 6.5 minutes. So after this, we'll open it up, and I see we have one at the mic already. I believe that there's a lot of power in bringing new ideas to the table from different fields. And NASA has run for a long time programs that are basically contests to draw in participants from outside fields. And a good example of a success of this is they did a very small like a $10,000 prize, because they had a bunch of astrophysicists trying to get noise reduction on the images. They've got images of like really distant nebulas, and there's dark matter interfering, and so they need algorithms to do it. And damned if this first-year glaciology student at some university doesn't turn in an algorithm that outperforms everything they've developed over the past 15 years. And it's something that's standard practice when you're looking at glaciers and you're trying to define the edges better. And so it's that kind of thing of you've got something somewhere that is not a traditional participant in this industry, and it's a brand new insight and a serious step forward. And I think there's a lot of opportunity for that as the business of space exploration opens up. And so I wonder what your thoughts are on the sort of non-traditional skill sets and how they can be applied to AI, robotics, space exploration, building bases on other planets, and all of the things we're diving into.
It's a great question. What we're trying to do in exploring space, I've alluded before to the fact that it tends to be very complicated once you look at all the parts together, right? Building one rocket is not that complex when you give me good specs for what you want to build. But building the right set of rockets to do a whole suite of things is a hard problem. It would be wonderful to do a Wikipedia-like exercise where you could actually pull in input from 1,000. So the target that I put in front of myself, and I don't know how to do this yet, but I think it's an important one for us to look at, is let's assume we had 20,000 people on Earth contributing to the design, and the problem I've looked at is the design of a greenhouse on Mars, right? Contributing to the design of a greenhouse on Mars. Clearly there's a dozen people I can put in a room that are the right dozen people to put in a room. And then there's probably some plumber in Scandinavia that has a wonderful technique for connecting pipes seamlessly in incredibly frigid environments. So how do we do that? And I say that in a way that, so it's more complex than something like Wikipedia in that these parts really have to integrate together. So it's much more like building AutoCAD design with a lot of people around the world. And if you have 25,000 contributing every day, how do we prune that? How do we do that in a way, and you know that 99% or more of that's useless garbage, right? You know that, that's just gonna happen. So you're ending up, you don't want to take your best people managing 99% of that, but there is incredible knowledge
It's-
in the collective.
That's a fascinating, that could be sort of, it's like an open source challenge almost. I bet there's lessons from that. So before we run out of time, let's hear from you.
Yeah, thanks. You're just touching on the question that I was going to dig into, which is the implications of the cost reduction and the mass to the surface of another celestial body that's happening, right? So if we're going to have a Mars base or a Moon base, but Mars is more technically challenging, and we're going to set up a fuel depot and set up a greenhouse, and the robot, can you talk about the complexity of building and testing robots that can set those up by the mid-2020s when we're talking, or maybe early 2020s by the time we have launch dates come?
Well, as most things in robotics or planetary exploration, you try to punt where you can. You try to find easy ways around it. So in fact, we have inflatable habitats that we can actually just set down and inflate, right? We have structures that we can build. Eventually, we would like to use a lot of in situ materials for resources for the construction part. In terms of resources like water, you have to find a good place to do it, and it's very much specifically designed to the task at hand. So the surveying part of that, which you need to do ground surveying prior to do that kind of in-depth mining, the surveying part we fully understand, right? And the mining part we fully understand in the sense that there's a great deal of automation in the mining industry on Earth. That is not bridged into space yet, but we fully expect to use that.
Unfortunately, there's become a partisan political divide, and completely unnecessary, between going to the moon and going to asteroids. And the West Coast tech community and the scientific community favors asteroids because that's where there's a lot of wealth. But the asteroids are only economically superior to the moon by delta V, but not by time, which means, of course, we can't go to the asteroids with humans. We must use robotics. So if you could comment on how important robotics would be to be able to get access to that spectacular motherlode of wealth that's in the near-Earth asteroids.
Yeah, that's a great point, dude. I didn't say much about it, but these are harsh environments that you're going to. And the robots in all of them are going to be a critical component to humans. They are sometimes simply going to be a smart plumber's tool, sometimes a smart shovel, sometimes a smart mule. But, I mean, you said it well. If you go to an asteroid, most of that work is going to be done robotically. And how do we manage the efficiency of that process? How do we get the right tools there? Yeah, I mean, I think it's a great point. I don't know that I have much to add to what you said.
And on the button, we are done. Thank you very much. Thank you.
Thank you.